When we carry out lifting operations, we rely on the integrity of all of the equipment that comes under load. When we move reels of paper up and down the production line, we generally have purpose-built beams and hooks that can safely and efficiently be used to move the reels, as well as loading and unloading the machines. Of course, not all our lifting operations can be done like this. We often use cranes with a range of lifting accessories to complete the lifts. Some of the most common lifting accessories we use are chain slings, webbing slings, round slings, and wire rope slings. We often use these slings in conjunction with other lifting accessories such as shackles, eye bolts, lifting points, and other specialised attachments for lifting particular items. In addition to that, we don't exclusively use cranes to lift our items. We may use chain blocks or other hoists, sometimes powered and sometimes manually operated, and there are also times where we apply forces to move or hold equipment. For example, we may use manual chain hoists to apply large forces. Whether the task is purely lifting or it is about applying mechanical force, it is absolutely essential that all the components used in the entire arrangement are in good condition. If any lifting accessory is damaged or compromised by the way it is being used, this can lead to the failure of the entire system, and the consequences can often be catastrophic. Let's look at a few examples of how the failure of lifting equipment can be sudden, unexpected, and ultimately devastating.
Что-то она у них раком стала ходить, блядь. Поворот рано. Править надо будет. Так это хорошо, еще не в рог, блядь. Ой, ой, ой! Ебать копать! Ебать копать! Зафиксируйте, блядь!
Машину заводим, да? Пробили танки, ёп.
Где танки пробили?
Ну вон сверху, блядь. Или танки.
You must never use any lifting accessory without firstly checking it for defects. If you find a defect, or you are not sure if what you have found is significant, you must not use the equipment. While it may be inconvenient to quarantine damaged equipment and to locate alternative equipment for your task, it is absolutely essential that you do this. Never take risks by using damaged equipment, and never leave damaged equipment in a place where others could find and use it. Remember also that you must only use equipment if it has the correct coloured tag in place. There is a quarantine box beside each lifting tackle store. Please use the nearest quarantine box to store any equipment that you find to be damaged. Similarly, if you cause damage to equipment during use, please take the damaged equipment to the quarantine box. We will look at how to inspect equipment in a moment. However, so that you can appreciate the significance of using damaged equipment or using equipment in the wrong way, let us look at what happens to slings when they are tested to destruction. This is the test rig used to test our slings. Let's firstly look at what happens to a new sling. All slings are designed for a particular load, but they will eventually fail. Never use slings to carry a load that is greater than the rating on the sling. A good sling will fail at around the predicted maximum braking load. Now let's see what happens to a sling which has a cut of just a few millimeters at one side. Not surprisingly, this becomes the weak point. However, the key thing to note here is that the braking load is reduced by 25 to 50%. A face cut is a slight cut to one ply the entire width of one side of the sling. In this case, the sling fails with a reduction of 30% to the standard predicted braking load. Face cuts could occur when slings are used to lift on a sharp edge. This is why you always need to apply packing to protect slings from sharp edges and corners. You should never tie knots in slings. This is really important. The very fact that the sling has a knot in it means that it will fail at this point. As the knot tightens, it actually cuts in itself, causing the failure of the sling, and a loss of around 60% of the maximum braking strength of the sling. When attaching a sling to a shackle or lifting eye, make sure it is of a suitable size to accommodate the sling. When there is not enough space, this causes the sling to bunch up, and again we find that the braking strength of the sling is reduced by around 35%. Let's now look at how we can go about inspecting each of the different sling types that we use on site.
Well, we're going to cover a few items on rigging inspection. We're going to start with synthetic web slings. And I've got a 1-inch 1-ply I&I sling here. Notice we'll be looking at information that is contained on the tag that needs to be there. And very quickly on the inspection, once we've satisfied that all the markings are there appropriately, I start at the far end, right up here at the eye, and I use my hands and fingers to really figure, do we have cutting and crushing? Do we have hard plastic surfaces that might indicate melting and charring that maybe don't discolor the webbing very much? But so I'll work from the eye, go down both sides, open the throat up, take a look inside the throat. Any broken stitching, I'll be looking for that, or any damage. Cuts, crushing, pinching, broken, torn, snagged yarns and fibers. All the face, front and back. And then I'll work my way right down the sling quickly, rotate, inspect, sweep with my eyes left and right, back and forth. Come down, look at the end of the splice. I'm not losing any stitching there. Roll, roll. Continue on to the next splice and work my way right back up to the other eye. So I'll open that eye up, feel up underneath and see if I can feel any damage, any crushed areas, cuts, or heat damage, etc., or any chemical damage potentially, and look in the throat. So that sling should be in good shape, ready to use, ready to go. We picked up a damaged web sling to help put a visual to some of the inspection criteria, and you'll notice we have a significant abrasion right along the body surface and a little bit of peeling of the fibers and yarns there. Discoloration is starting to look like a little bit of UV, ultraviolet ray degradation, but that would be the leading indicator for cause for removal. And the reverse side has a little bit, and I'll hold that so we can get a shot of that. A little bit of abrasion, but certainly on the front side, we would have suitable damage there to remove that sling from service.
Look for broken stitching, burn, tears, punctures, surface cuts, or edge cuts. If the sling contains any of those or excessive abrasion, the sling needs to be removed from service. If there is a knot that I am unable to get out, that sling needs to be removed from service. Lastly, if your web sling is faded or brittle, it may have damage from UV light.
We should be very cautious about using damaged slings of all types because the breaking strength reduces and the working load stays the same, but ultimately our kind of in-field design factor has changed and we get a little bit of dynamic loading and we can blow right through that piece of gear because its ultimate strength is actually reduced significantly. So we want to be very respectful of what we do with the damaged rigging and respond quickly. When we see that damage, we want to get it out of service. Let's talk quickly about synthetic round slings. So let's take a look. We've got a good marking on the sling, very much like our other sling type inspections, but we're going to take a hard look at the closing area for the sling, sewn down with the tag, generally. And I'm going to feel down through. What I want to feel is a continuous bundle of fibers all the way through the body because it's a continuous rotation or wrap of yarns that make up the body dimension for inside the round sling cover. So once in a while we'll feel a little knot where they've tied the beginning to the end, or some packaging tape where they've sort of gathered the yarns together. Don't worry about that. But we're going to feel all the way down and look at the sling, and I'm going to turn it, rotate it, drag and pull the sling through my fingers hard. I'm trying to see if I can feel any hard plasticized area that might be heat damage or other chemical damage of some type. We're looking for any separation in the cover. So as cut cover exposed core yarns is a removal criteria.
There are 2 layers of the jacket to protect the interior core yarns. If I find any areas where there is a cut or a hole and I'm able to see any of the white interior core yarns, that sling fails inspection and needs to be removed from service. If the cut only penetrates the outer layer, the round sling still passes inspection and can be used. If I find a burn in the sling, even if it's only to the outer layer, I have to make an assumption. I should assume that there is heat damage to the interior core yarns as well. Internal heat damage can be identified when the internal core fibers have a brittle feeling or contain abnormal lumps.
The thing we get here that we get away with a little bit is any UV damage on a round sling really isn't significant. It's on a flat web sling. So we're still looking for cut or broken fibers inside. We're looking for cut cover to exposed fibers, illegible marking, chemical damage, heat damage, and other things that we know might take muscle away from the sling. So there we go. We've got round slings covered.
When I begin the inspection of a wire rope sling, I first want to make sure that I'm wearing gloves to protect my hands from any broken wires. I first look to see if the sling tag is present and legible. If so, I begin my inspection. When inspecting the wire rope sling, if I find that there are more than 10 broken wires in one rope lay or more than 5 broken wires in one strand, such as here, I need to remove the sling from service. The definition of a rope lay is the length of rope in which one strand makes one complete revolution around the core. I'm looking for any crushed, bent, kinked, bird caging, or broken wires. Here I have broken wires in the body of the sling. I know this sling fails inspection. I also have broken wires in the eye of the sling. Whether the broken wires are found in the body of the sling or the eye of the sling will need to be removed from service. The wire rope does not need to lay perfectly flat on the ground, but when it has a severe bend such as this, it will need to be removed from service. When inspecting wire rope, it can be difficult to identify corrosion. When corrosion is seen on the outer layers of the wire rope, it is likely that the interior wires are also damaged, and the sling should be removed from service. If any other damage is found that causes doubt as to the strength of the sling should be immediately removed from service.
Very good. I know that there's a lot of alloy chain slings in use in the field. I'm going to drag this open. First, we always want to take a look and get down to the tag and identification that it's all properly marked. In this case, it's a single leg sling, and we need a working load limit, the grade of the chain, the length or reach, which is measured from bearing point to bearing point, needs to be stamped or marked. Number of legs, if more than one, should also be in manufacture, and the size of the chain, of course, in concert with its reach. So let's take a look. We start in on the tag confirms everything is good with the sling, so we'll start with the master link and ensure that it is straight and true all the way through. And then in this case, welded link, we'll start there. Take a look and see if we have any exceptional moon or dishing and the link-to-link contact. And what I'll do then is I'll work on each section of chain and roll that chain over, see if I can find any dimples, damage, elongation, collapsing of links, heat damage, corrosion. And I'll just move that chain in 4 directions and then continue to roll, sweep my eyes left to right, continuing to look for a change in the pattern of the chain bodies. And roll that over 4 times so I can see. And then I'll work my way right down to the hook end, all the way down to the last welded link inside the eye of the eye hoist hook here, and look at the contour of this hook and the wear and metal loss and the alignment of the hook, whether it is bent sideways or if it's tip loaded. Okay. This is sort of the bad chain, and we have some incomplete tag information here. It's noted as a 2-leg assembly because it's got 60 degrees marked. So I'm missing a leg on the sling. So I already know it's a problem, but just from a physical standpoint, I'll take a look with you. This one has mechanical couplers on it. Very hard to hinge the coupler. I would strongly suspect overload. That could be easily an issue or a concern. Down at the hook end, we'll notice right here we actually have sheared off the cotter, and there is that load pin is welded in place, tacked in place. It's a grab hook. You know, we've already found a rejectable component there, rejectable component with the coupler, and so on. Let's take a look and see if we can find any other. And I'll take that lower end versus the upper end, do a quick comparison on that. They look about the same, but the chain looks like it's been, wow. So as I roll this in my hand, something you might do, I'm pulling on that chain and then trying to roll it left and right, opposing, very stiff. It looks like the links are actually collapsed. And compared to a newer chain, you should be able to hinge and work that chain back and forth very easily. But this chain just is very stiff. You know, right from the get-go, I think we got a bad sling here. Coupler, hook, elongated chain legs, mismarked, mistagged, everything else. So we'd want to retire this and get it out of service.
When conducting the chain inspection, if you can see with your naked eye that the sling has stretched or bent links, it is a good indicator that the sling fails inspection and needs to be removed from service. I'm looking for damage to the chain. If I find any bent links or nicks, gouges, or cuts that get through the hardened outer layer of the chain, I need to remove that sling from service.
All right, these are just some pictures of items, some of the items that we're looking for: bends, twists, stretching, interlink wear, heat damage, nicks and gouges, knots, homemade hardware. These are things that you do not want to see out there. All right, adjustments, you can see here how they took a couple of bolts and just twisted a couple of links to the side because the sling had stretched, and that one side of the sling got a little bit longer than the other. They needed to back it off. So again, these things are not things that you want to see out there for the lifting world.
Thanks.
In this training session, we have looked at why we need to inspect various types of sling prior to use. We also understand the need to respect all lifting equipment when using it, and we have seen what happens when damaged equipment is used, as well as the consequences when it fails. The training has also shown us how we can conduct our own inspections on various types of slings, and we can apply these principles to inspecting any of the components used in our lifting system. We understand that deformed or damaged equipment can fail unpredictably and at much reduced loads. While we have looked at many of the typical defects that would cause us to quarantine substandard equipment, it is important to say that if you have any doubt about the significance of any potentially substandard features that you have identified in your checks, you must not use the equipment. If at the moment you do not have much experience in carrying out these checks, get a trusted and experienced colleague to work with you and confirm that your judgment is correct. Ultimately, ensuring the safe condition of any lifting equipment that we use is fundamental to the overall safety of the operation. Never take risks and always report and remove damaged equipment.